Welcome everyone, my name is Jeff Smith. I'm the product manager for Oracle REST Data Services, also known as ORDS. And for the next hour or so, I'm going to give an introduction to the concept of REST. If you're a database background type person like me, this might be kind of new to you or completely brand new to you, and I want to take a second to explain those concepts before we jump into the tech. I'll give an overview of the product, and then we'll end with some quick demo. My contact info is here. I invite you to email me or tweet me, and I also have lots and lots of blog posts that cover some of these concepts at thatjeffsmith.com. I'm going to tease just two little features we've got coming down the pipeline, and since I'm going to talk about features, I have to show you this piece of legalese. It basically says please don't make buying decisions based on what you're about to see. Okay, so this is the technology we're talking about today, ORDS, otherwise known as Oracle REST Data Services, formerly known as the Apex Listener. ORDS has two primary features. One is to bring a REST interface for the database, and the second is to act as a gateway or web listener for Application Express and other things in the database. There's no requirement to run Application Express with ORDS, and you can run ORDS without Application Express. So they're completely independent of each other, but they also work quite nicely with each other. What I'm here to talk about today is the REST and the RESTful services that ORDS provides for the database. So before I just jump into things and assume you're up to date on representational state transfer, I want to just take a few seconds to get everyone on the same page. So the reason ORDS has become more and more important is REST has become the go-to API for the entire application stack, or actually the entire IT stack. Folks are able to spin up Docker images, create machines, or virtual images. They're able to install software. They're able to perform upgrades. They're able to take backups. They're able to create operating system users, grant privileges, everything via this REST API. And folks like it because it's easy. It's a fairly simple model once you get your head wrapped around it. And what we don't want is for this well-oiled machine to come to a complete stop when you have to start working with the database. So we want to provide this easy set of operations like gets, puts, posts, deletes over HTTPS. And make that available for the database too, so that you can stand up the database and take database backups and get access to the data in your database and make changes in the database via the same REST APIs you're doing for everything else and in your IT stack. So one of the reasons REST has taken off is because, again, like I said, it's easy. It's basically how the internet is structured. Although HTTP, putting HTTP on something isn't the same as saying it follows the REST model. So I'll talk about that in a second. Most folks are familiar with the status codes, especially 404, page not found, when you try to pull up a web page that isn't there. But we also know what 500s mean, something very bad has happened. 200s and 201s you don't normally see when you're working in your browser, but you'll see those a lot when you're dealing with these REST APIs. It's very link driven, and it's to make it so you can have stateless environment. So what that means is I can come in and make a get on a resource and get that output back, and I can make that same GET request over and over and over again and not worry about where I came from or where I'm going. And a lot of those times those responses will include links to kind of guide you where to go next. in your application. When the database comes into play, the stateless behavior in REST model becomes very important because basically we're in a non-transactional mode. So we're not carrying transactions across requests. We're almost in an auto-commit state of being. Okay, so you can't put HTTP in front of something and say you've got REST. So it's important to model things in the database as a resource. So in this example, I've got something called employees as a resource, and we perform verbs against that resource. So I have this thing called employees, and I'm going to get or put or post or delete on employees. I am not going to create a resource called delete imp and do a get on that. So for someone who's running around different REST APIs, they come across this API you've published for them, and you give them this resource called delete imp, and you say, look, just perform a get on that to delete an employee, they're going to be confused. They're like, I thought we used delete to delete employees, and here I am doing a get. So it's important when you start to build these REST APIs that you follow the REST model so that they play nice with everything else in the ecosystem. So we have this resource collection pattern, and it's very simple. So we have the master resource. In this case, we've got employees. And that trailing slash is important. Kind of think of that as a directory listing. So you've got employees slash, that represents all of the employees. And then you have a detail resource, or just a single item. And one way to represent that is you've got the resource slash, and then you've got some sort of ID that tells you exactly which item in this resource that you want. So that's the pattern. Let's look at this a little bit more basic. So let's say we've got, we always do HTTPS because that's secure. You've got your server where ORDS is running. When we get to /ORDS, that tells ORDS it's in charge. And then we have this routing pattern of an alias that tells us what schema that we're going to be operating in the database. And then you've got something after that, either a RESTful service module, or you've got something that's been REST enabled. So we'll stay with employees because that's something everyone's familiar with. So I've got this employees table in the HR schema that's now accessible over HTTPS. So anyone that can make a web call, that could be a web page, it could be any application, it could be someone at the command line using a program called curl. They could be using one of dozens of REST clients. I'll be using something called Postman later that I'll take you through very quickly. So this is the address where I want to go do something to this employees object. If I put this in the browser and go in the browser, it's going to do a get. And what I would get back if I were in SQL Developer, I'd get a list of tables back. In the REST model, in the REST world, the JSON structure, the JSON format is the most popular. So you get something back that looks more like this. Employee ID 25. Oops. This is what you get for doing live demo. 25, and then you get, by the way, it won't be nicely formatted like this, it'll just be flat. And you'll go down until you get to the end of that record. So this would be the response generally when you make a REST request on something like a table. So actually, this would be one employee. All of the employees would come back as a nested doc of this. So I'd have many employees bunched up together in this JSON format. However, if I were to come up here and add 25 to this URI or URL in your browser, what I would get back is just employee 25. If I didn't do a get on this and I did instead a delete, ORDS would go into this table and delete employee 25. If I did a post, and in this post request I included a record, ORDS would update employee 25 with the characteristics in this document. And if I did a put to not 25, but I did a put to just HR employees, again in the put request body, this JSON document would get inserted as a new item in the employees collection. So what ORDS does is it provides an interface to the database via HTTPS following this REST resource model, and it uses these verbs like a get, and it translates it into a SQL select. Or it takes whatever you have defined in the REST service into the equivalent database workload. But in general, you'll see gets come in as selects because, again, you're asking for a resource and we're just going to query that resource. But you could also do put, post, and delete. Those are the most frequently used ones. You saw this word listed here several times, say for idempotent. Post is definitely not safe. Really, anything can happen when you do a post. That means that the resource that you're interacting with, it could get destroyed, it could get changed. Idempotent, what that basically is saying, you can perform an action on it and it's unchanged, and you can do it over and over again and not make any problems. The example that I heard that stuck with me is if you get something pregnant, you can perform that action over and over again. You can't get more pregnant. Its status is going to be unchanged. It's not the perfect example, but it made me laugh when I heard that, so that's the one you're hearing from me today. So here is an example of a REST call via the browser. Again, this is a GET, and you've got the results that come back. So here's that, what we got here. So I've got something called HR, peeps, expensive, and 100. So I think this is a module called peeps, and then I've got a service called expensive, and then it accepts a parameter which I'm passing via the URI, so 100. So I think I'm asking for the 100 most expensive employees, and it's returning back this JSON document, and then it also returns all of these links. So this is where this data came from. This will describe what we're looking at. So this metadata catalog It's kind of like, well, I think it's pretty aptly named. It's the metadata behind this call. So it'll describe what we're looking at. And then we have a link to the first record in this set, and then we have a link to go get the next set of records. And these are pretty common sets of links that you'll see in any request back from ORDS, generally, if it's appropriate. This allows your web page to get a list of things, print it, and then give someone a button to click to go get the next set, for example. All right, so how do we get the stuff that's in the database or the database itself, and how do we make it accessible via HTTPS? So Oracle REST Data Services is a Java application that would generally sit in a mid-tier, so theoretically not on the same box as your database, although it could be. And you can run it inside of WebLogic if you have that licensed, although most of our customers will use something like Tomcat. We also support Glassfish. So those are just kind of Java application servers that generally will sit behind something like Apache, or they'll have their own web server in front of that. But you can also run Oracle REST Data Services as a standalone application, and it's got its own built-in web server. It uses something called Jetty, which is an open source web server that's pretty popular out there. But basically what's happening is at some point the web server, or ORDS, if it's acting as the web server, is going to receive your request, your get, your put, your post, your delete, to the URI, /ords/HR/employees/101. And ORDS is going to get that, and it's going to say, okay, I need to transform that URI. I need to figure out what that represents, what's going to get called because of that. And anything that happens in the database, surprise, is getting to get executed in the database via the database language, which is SQL or PL/SQL. So ORDS has a series of JDBC connections open to your database. So it's got a connection pool. And so when these requests come in, it goes, okay, this connection should go to this pool, to this database, to this user. Figure out based on what's in that database. Is that in a table that someone's REST enabled, or do they have a custom RESTful service? In any case, the SQL for that is determined, and then it's executed on that connection. We get the results back. Those results get transformed to JSON, and they get posted back down to your client. So that's really all ORDS is doing. It's providing access to the database. It's implementing that REST model, and it's translating from the REST verbs, get, post, put, deletes, into SQL and PL/SQL to execute to make things happen in the database. And it's very good at taking a JSON document and parsing that and translating that into input parameters for stored procedures, for example. And it's also very good at taking the results of a stored procedure or a SQL statement, like a CLOB, if you've got cursors or nested result sets, and translating that all back down into the equivalent JSON result set. So that's what ORDS at the end of the day is doing. This is kind of just a simpler thing of this, the exact thing I talked about. So if my URI is ORDS sees this and goes, I know what database this is, I know what user this is, I know what object this is, I know what resource this is, and I know the SQL that needs to be run to satisfy this request, whether that be the get, the post, or the delete. And so it would go do the insert, update, it would go do the select, the update, or delete based on that. And it gets that nice data back, and it sends it back down in the format that your application expects, which again is JSON. And then your application can do all the fancy stuff with that. Paint it to the screen, throw it in a grid, animate it. There's a bajillion of libraries out there to do cool stuff with that data format. Alright, so this is just a diagram of what I tried to explain earlier. So you've got ORDS that is probably running in something like Glassfish or Tomcat. If you've got WebLogic licensed and available, it runs great in that as well. Or again, you can run as a standalone web server itself. Front-ended by a web server like Apache, so requests are coming in off the internet on Apache. It gets routed to ORDS. That's what that /ORDS will do. ORDS then has its connection pool to the database, one or more databases. It does the results, gets it back, and then eventually that stuff comes back down to your client. Okay, hopefully I haven't made this sound overly complicated. It's actually quite easy to get running with this, even for a web developer noob like me. So one of our internal folks was able to stand up ORDS and deliver a set of web services for their database in just a few hours. And I've had that same conversation with other folks. So how can we make it easy for you to get started? Well, we've done two big things in the last 2 years to try to make this easy as possible. For one, you can do all of this from the nice graphical user interface that you have in SQL Developer if you want. You can do all this from the command line as well. It's just a simple Java application that you can run and script to start up automatically on your middle tier if you'd like. But you can also write on your laptop, install configure ORDS to run to connect to your database to experiment with. We also provide a VirtualBox appliance that's got Oracle Linux running on it, database 12c release 2. Has Application Express 5, and it also has Oracle REST Data Services, all set up, configured, ready to go. And we give you a series of hands-on labs that you can walk through that show you how to REST enable a schema, how to publish a REST service, how to secure it, and even how to build a web application based on those REST APIs that you've deployed. Alright, so when you go to install and configure ORDS, you have two choices. You can use the command line interface. So you'll just go to OTN and download ORDS. It's like 45 megs. You'll unzip it. There'll be a WAR file in there. Of course, you need Java on your machine because it's a Java app. So you say java jar ords.war, and then you would throw it the install. I chose to run with help instead. And it's going to ask you a series of questions, and when it's done with that, it's going to start running and you'll be good to go. Or, if you'd like, you come in SQL Developer, which already has ORDS inside of it. You go to Tools, REST Data Services, Install, and you get a 9-step wizard. After you've configured, installed, and started ORDS, you can't do anything with your database until you give us a database user to do stuff with. So really what you're doing is you're going to do what we call REST enabling a schema, which is going to provide for us a place, it's going to provide for us a user to run your transactions as. So when I REST enable this user called ORDS demo, when ORDS gets a request that gets routed to this schema, it actually changes its connection to the ORDS demo user and runs everything as that user. So you inherit the privileges and what you can do in the database from that schema that's been REST enabled. It also allows us to map things in that schema, including RESTful services that you've programmed, or objects that you've auto-rest enabled. So you can do this using the PL/SQL API. So this is an example of what this looks like. Or you can come into SQL Developer and right-click on a connection and say Enable REST Services. Now I believe I've already enabled REST Services. Yep. So you say enable the schema. Now I think this is important, or I think you should consider doing it. You can provide an alias, so you're not exposing the name of the user of the schema to anyone that has access to your APIs. So they only know of this pattern peeps. If you have HR there, they might assume, oh, that's the HR schema. Now I can go try doing things that you don't want them to do. And you're also going to want to require authorization, which secures the URI. I'll talk about security later. All right. Excuse me. All right. So once you have enabled the schema, you can now start building things in that schema, basically. So you can deploy or publish your RESTful services to that schema 3 different ways. You can use the PL/SQL API. So if you've got access to the database and you're comfortable with SQL Plus or SQL CL or SQL Developer, you can write your RESTful services using this ORDS define module package, define template and define handler to go out and make these things live. Or you can use the editor interface that we have in SQL Developer itself. So we have this REST data services item under the connection tree where you can go and define your services. Or if you have ORDS on a database configured, but you don't have database access, you can actually use REST. So we have a REST client inside of SQL Developer that lets you connect to the ORDS server versus the database and publish REST services that way. The easiest way to go is probably this middle one right here. Okay, so when you go to start defining and deploying these services, you've got 2 options. You've got the automatic mode and you've got the manual mode. By the way, in either case, you don't need to know Java. Really all you need to be familiar with is the language of the database, which is going to be PL/SQL and SQL. So the manual mode, you're going to create something known as a module. And modules are kind of like a package. It's like a way to organize and collect RESTful services together. That makes sense. But behind or inside of these modules, these RESTful services, behind those, what you're going to have are either PL/SQL blocks or SQL statements. Because again, someone's going to make a call, a get, a post, a put, a delete on a resource that's going to get mapped to one of these things. And for ORDS to say, okay, they want to go do this thing, what does that actually turn into? Well, it turns into this code getting executed in the database. And since these are web services, you're able to do things like define how to send things out in your response, or how to pull values off the request headers. You can control the page size for the results. What else? You can set the MIME type, so you can say what's coming back. It's going to be a JPEG. Maybe you're querying a blob. You want it to come back as a picture versus text. So you have lots and lots of control over this method. So the manual method, it's basically up to you to do everything. ORDS is giving you the interface, or just giving you the security around it and the structure, but you've got to provide the code. The automatic mode is where I see a lot of people starting with, because they just want to get up and started with the ORDS very quickly and see what it's about. What this allows you to do is to say, for this table or this view or even this stored procedure, I want ORDS to define that API for me and to handle all of the code for me, and I don't want to have to do anything. So you can right click on a table, say enable this table. Again, you can alias it, and again you can secure it so someone just can't come in and access it without proving that who they are and proving that they have the ability to come in and work with this table. And for example, on the tables, the API that we build for you automatically with zero code is huge. So you get the ability to query one record, query all records. You can even provide predicates on those queries via the REST call itself. So if you don't want all employees, you can say just give me the employees that make more than $2,500, and order those by first name ascending if you'd like, just by manipulating the URI patterns. We also give you the ability to insert, update, delete records, so it's full CRUD. And then as a bonus, we give you the ability to bulk load employees or records in this case, using a CSV that you attach. And then we also give you a describe, basically. So one PL SQL call or one right click in SQL Dev, you got ORDS running, and suddenly this entire table, you can do anything you want with it via REST. So let's see, I've got some of these tables REST enabled. So I've got a scheme in here called ORDS demo. It's in REST enabled as auto demo. And I've got tables in here. I've got one called dtypes, and it's REST enabled as types. So let's go play with that. Let's go do it in a browser first, because again, browser's the easy way to go. I didn't do demo. ORDS demo is enabled as auto demo. Yep. Okay. So I've effectively done a get. I've activated ORDS. I've told it the schema, and I've made this metadata catalog call, which basically says publish for me the API that's available in this resource, which in this case turns out to be the schema. So here is this table, dtypes, which is referenced as types, and I can get the API on that here as well. Okay, so this is everything that's available on this table. And so this is a JSON description of the API. So I can do a get, I can do a post, I can do a get on an ID to get just a record, I can do a put on that same thing, and I can do a delete. The nice thing about having access to this metadata catalog, by the way, this is one of the new features that's not in production yet. The metadata catalog feature is there, but it's not producing the Swagger output today. But the next version of ORDS will produce the Swagger content, and you can take this JSON and paste it into a Swagger editor, and this is great for producing API docs for your REST interfaces. So here's that same JSON that ORDS produced for me, and then over here on the right I have a test client basically that allows me to exercise these REST API calls. So for example, if I want to try out the get on this, I can do it. And to make my get request, any parameters? No. So I can hit this execute button, and it'll get me the values of everything in that table back as JSON. And while it's working on that, curl is a command line interface. It's basically C plus URL. So you can make these get, post, put, delete calls from a DOS prompt or from a bash shell. So my response, I get that 200 code back, which means all is well. And then the response body has the values of that resource in that JSON format. So, happy day. Now there's two gets in here, so I can do a get on slash, which is the entire collection basically, or I can also do get on one item in that. So in this case, I'm going to do a get on, now I've got to pick one of those records. And if we come into and look at this table, these are the records. So I'm going to do a get on that record, and I'll get back just that record. These are normally suboptimal. These are sub-second response times generally, but I've got ORDS running on my laptop, connecting over VM while I'm also running this recording software, so it just kind of slows stuff down. So here is just this record. Okay, gets are pretty boring. You could go run this in your browser if you wanted to. More interesting, post and put. So I can post up this record. So we're going to basically post a new record into the collection. So what ORDS allows me to do is attach to the request this JSON document, and what I have here are the columns, the column names and their values. And ORDS basically catches those and translates that into an insert into values and runs that. But you don't have to write the insert code, just like you don't have to run the select code or the update code. So this response will be a little bit different from the 200s. What I get back is a 201, which means that you successfully added an item to the collection. And it returns back the new item with a link to that item. We can also run a put, which would say put to 23. So we're going to change item number 23. In this case, I've changed MJ to Michael Jordan. We'll execute that. And so ORDS in the background is basically running an update. Yep. Now if I come over here and refresh this table, I should have a new record, and it should say, yep. I could also change this record. Should work, I think. If we come refresh, yep, ORDS demo. All right, so this Swagger stuff has nothing to do with the ORDS tech. Swagger is just a nice documentation library that's out there that you can use to take your REST APIs that you've built and dock them and share them with others. And again, that's one of the reasons why REST is so popular, because it's very easy to generate these API docs. I've got another program called Postman. This one's also, I think this is open source and free, but it allows you to create basically a library of calls that you can run and play with. So, for example, here I can do a post to this table, and this is the batch load. So I'm attaching to the request body or the post body the CSV record, and ORDS knows to automatically turn that into a series of insert statements. So that's the auto. Now, kind of breaking the REST model a little bit. If you want to have your stored procedures available to be called via ORDS, you can do that. So you can REST enable a package, a stored procedure, a function, and what we publish is a URI that you can do a post to, which will have that piece of code executed. So the REST model doesn't apply because there's really no concept of a get or a delete or a put, and we just got post. So really, instead of calling this REST, it's using ORDS to give you remote procedure call over HTTP. But it uses the same security model, it uses the same method for resolving these objects in the database with the URI patterns. And you have the same SQL developer support. You can right-click in SQL Dev to enable it. And it also has the really nice JSON streaming in and out. So to execute a stored procedure, you pass up the parameters to execute it in a JSON document to the post request. And then the output that comes back, we capture the ref cursors or any outs or returns, and we translate that to JSON back. So this kind of looks like this. If I've got a stored procedure enabled, you make a post, and this is a ref cursor that comes back. And inside this ref cursor, I've got all kinds of stuff. I've got timestamps. I've got this is a interval data type. So it's able to deal with pretty much every data type that you're going to run into to get that back into JSON. Here's just a really boring one. So I can make the same post. It's got an input called string. So to execute this, I include the JSON document, and I say, look, you're going to need this value, and what it's going to be is this, because I think I last demoed this in Montreal. And ORDS is going to end up executing this procedure, and it's going to insert into a table called thick insert a string, and it's going to be that value from that JSON document that's going to end up going in. Here's what the metadata catalog calls look like today. So this is not using the Swagger style that you can use to generate the Swagger doc, but they're still useful. The Swagger support is coming very soon. I wouldn't be demoing it to you today if it wasn't going to be coming down the pike very, very soon. But the metadata catalog endpoint is definitely there on the schema, and then also anything in that schema that you've published as a resource. I did not demo the custom REST services. So let me do that very, very quickly. So in our REST enabled schema, you're going to have this REST data services thing inside of SQL Developer. Now you're going to need SQL Developer version 4.2 or 17.2 to see this REST data services item in the tree. It's somewhat new. And let's look at some of the things that I've got in here. I've got one called dbmon, and then I've got a item in here called sessions, and I've only put one handler on this service. So when I do a get on sessions slash, ORDS is going to run this SQL statement to bring back what looks to be like a list of sessions. So I've REST enabled HR as peeps. So we're going to go to ORDS, peeps, and then I've got dbmon and slash sessions. So ORDS found that in my published list of services under the HR schema. It found that SQL and it ran it and it brought back the results. If I want to change this, maybe I don't need the sys_state. I don't even know why I added that to begin with. I can simply change that in the query. Save this back to the repository. It's live now, and if I do a refresh, it comes back instantly and the sys_state's gone. This is a very simple one with a get, and there are no parameters or anything like that. Let's look at a get with a parameter on it. So in this case, I've got one called tweets, and the pattern is search / bind text. So to call this one, what is it? Tweet search. I can't call this or this. It's expecting a bind after it. So let's look for, what are we going to look for? This is basically a collection of all of the tweets I've ever tweeted. That's a big one. Yep, see, there's all the tweets I've ever tweeted that have the word SQL Dev in it. So it found that in my table. So the code behind that, it's pretty simple. So I've got select star from tweets where lower text, and then I've wildcarded that string. So I don't have to declare this text as a parameter. We automatically do that for you. We know to see that on the pattern of the get handler and to automatically feed that value to bind in the query behind the service. Select star from is bad. So let's get that and format that. Oh, my formatter's not working. You probably don't need all of these. I don't like select star froms. So basically I'm just trying to show you that you can build these just like you would build SQL like you're used to. So let's take those off. And let's say order by this is the table. Let's order that by tweet ID. That should be date driven. And we can test that. Make sure I didn't break anything. Yep, okay. So save. Come over here, refresh. Yeah. A little bit different. So I've changed the data that's coming back and I've reordered it. I'm not going to demo puts or posts, but I'll show you what it looks like. So the type of code behind this handler is PL/SQL. I have defined some parameters, so I'm going to send stuff back on the response. And I'm also pulling something off, or putting something on the header. So I want to change the status code on this. Instead of a 200, I want it to come back as a 201, basically. So you can do that. And we're going to execute this stored procedure and send some data back out. So that's why I have to define the parameters. You can do with a RESTful service and ORDS in the Oracle database anything that you can do with SQL and PL/SQL. So please don't let my generic boring examples hold you or your creativity back. All right. Before I talk about securing these, let me just remind you that we here at Oracle use ORDS to power our Oracle public cloud. So ORDS is front-ending things like apexoracle.com that has over 30,000 tenants in it. So that's more like 35,000, I think, people that are running and playing with Application Express on our cloud. ORDS is responsible for getting those requests and getting people into their workspaces and out. So it's robust. It can handle tremendous amounts of traffic, and it's also secure. So that was a free service. We have pay services that ORDS is also responsible for, and we're very happy with it. We've secured that using WebLogic and the sort of single sign-ons that you get with your cloud accounts. It's all integrated. So securing this REST APIs are important. For my demos, I generally demo with HTTP because it's just easier for me to set up on my laptop, and I usually run them with security turned off, just again because it's easier. But you want to start with security being up front, foremost in your mind when developing these REST APIs. And we give you a couple different ways to do it. You can do what's called first-party authentication. So this is ORDS specific. You can create an ORDS user, and you assign that ORDS user privileges. And when you secure a RESTful service, you say this is the privilege that's required. And when you come in and supply your username and password, which is not your database username and password, but your ORDS username and password, ORDS goes, okay, you are who you say you are. Okay, you have the privilege required. We're going to let you in. And then once you've given that, basically that cookie that says you're allowed, it's generally good, I think, for like 30 minutes, although that's configurable, so you don't have to go through the authentication process on every request. That would slow you down a bit. We also support OAuth 2. This is a bit more complicated, but it opens things up and it basically allows you to authenticate stuff however you want in your web stack. So if you're running this in Tomcat, you're going to say, Tomcat, you authenticate the people however you want, and it's going to pass those credentials down into ORDS eventually. So ORDS isn't making sure that people are who they say they are. Tomcat's doing that, and maybe you set that up with your LDAP, or maybe you're sending them off to someplace like Facebook to say who they say they are, but then when they come back, Tomcat's saying they are who they say they are, and then ORDS says, yep, it looks like they've got the privilege that's required for this service, and it's going to let them in. Single sign-on, we support. We're getting ready to add support for database authentication, which I don't think people would go with on brand new apps, but if you have older apps that require that, that's going to be supported. If you go look at the VirtualBox appliance that I talked about earlier, the hands-on labs are quite nice, and we have one for ORDS. And we show you how to secure your service. These are quite nice. I mean, they show you how to set up an OAuth client, how to secure the REST service, how to test it, how to play with it, and it's screenshot driven. So you're basically just walking the items. I was going to do demo here, but apparently I've been doing demos we've gone, so we don't need extra dog and pony show. I will end off with things that we have coming. So I've shown you auto REST enabling tables, views, stored procedures, although it's not really REST with stored procedures, remote procedure calls for stored procedures. I've shown you how to hand roll your own RESTful services, backended with SQL and PL/SQL. We're getting ready to start delivering a REST API for the database itself. So this would be automatic. You'll get that Swagger style doc set with your install. If you turn it on, you can start making REST calls to do things in the database like generate an ASH report, create a user, initiate a backup, get a list of backups, clone a pluggable database, delete a pluggable database. So we're going to we're going to deliver these in batches, starting with the next release, probably. So you'll install ORDS, you'll turn this on if you want. You'll, of course, secure those REST endpoints. And then you'll be able to come in and start interacting with the database itself, and we'll have written all of the code for you. You can, of course, start building these on your own if you'd like, but customers have told us they would like for us to provide those for them. So that's what we're working on. That's the end of the show. To learn more or to get started, it's very easy. Oracle.com/rest takes you to the product page for ORDS. Download YouTube videos, Twitter feed, if you like that. You can go to the VirtualBox. Just Google Oracle Developer Days VirtualBox. That'll get you to this link. Pretty much up to date. Like I said, 12.2, Apex 5.1, ORDS 3.09, and of course SQL Developer. Already good to go, and the hands-on labs, which start with installing ORDS, configuring ORDS, REST enabling a table, building your own RESTful service, and then securing it. And then if you like blogs, especially if you like the SQL Developer stuff I showed you with the ORDS integration, you can come to my blog, and I've got an ORDS category that steps you through stuff. And then you've also got Chris Rice, who's our development director and the inventor of ORDS. Talks a good bit on ORDS stuff on here as well. And you've got our forums, which are linked to here, and of course our docs. Well, I spent a little bit longer than I wanted to. I tried to keep this to an hour. Oh, 59 minutes, 48 seconds. Perfect. So I'm going to thank everyone for your time today. Please feel free to leave questions on this video, and I will get to them as quickly as I can. Thanks, everyone. Enjoy the rest of your day.